Sequence and series. In mathematics, a sequence is an ordered list of numbers called terms. The natural numbers forms a sequence. That is, all the terms in the sequence differ by a constant of 1. So we add 1 to the previous term to get the subsequent terms. So in general, u sub n is equal to n is the sequence of the natural numbers, where n is greater than or equal to 1. The even numbers also forms an arithmetic sequence. So they differ by a constant of 2. So in general, we write u sub n is equal to 2n. So if we have a general arithmetic sequence that differ by a constant of d, so we keep adding d to get the subsequent terms. Then in general, the formula for finding the sequence or each term of the sequence, which is referred as the nth term of the arithmetic sequence, is given by u sub n equal a plus n minus 1d. A series is an expression that indicates a sum of terms of a sequence. So if you keep adding the natural numbers and the sequence of the natural numbers, then we have formed a series with the natural numbers. The sum of the first n terms of an arithmetic sequence. If we add the first 4 terms of a sequence, we get something like this. That is a general sequence. So if you reverse this, we get something like this. So the reverse is the last one here becomes the first one over here. Now you can see that all these terms are the same. So we can add the 2 of them to obtain 2 times the sum of the first 4 terms equal this. You can see that all these are the same and we have 4 of them. 2a plus 3d, we have 4 of the 2a plus 3d's. So we can now simplify to obtain 2 times the sum of the first 4 terms is equal to 4 into brackets 2a plus 4 minus 1d. 4 minus 1 gives us the 3d. We just wrote everything in terms of 4. So we have written this in terms of 4 minus a certain number. Now, we want to make s for the subject, that is s of 4 the subject. We divide through by 2 to obtain this. Now we can see that the sum of the first 4 terms can be rewritten like this. What if you want to find the sum of the first n terms? So we just substitute n for 4 over here. So even though we can simplify this and get some expression, we want to observe a pattern so that we can generalize it. So we substitute n equal 4 for this. We obtain s of n is equal to n over 2, all multiplying 2a plus n minus 1d. So that is the sum of the first n terms of an arithmetic sequence. Also, if we know the last term of an arithmetic sequence, then the formula s of n is equal to 1 over 2 into a plus l times D, where L is the last term in the sequence. So let's take our very first example. We have the first term of an AP is 1.2, so A is equal to 1.2. Then the common difference is 2, so D equal 2, and we are finding the mean of the first 5 terms, which is the sum of the first 5 terms over 5. So this means that we need to find the sum of the first 5 terms, so we use the formula S of n equal n over 2 into 2a plus n minus 1d. So we sub in these values. S of 5 equal 5 over 2 into 2 times 1.2 plus 5 minus 1 times 2. Now this will give us 5 over 2 into 2 out. Then we have 1.2 plus 4, which is 5 minus 1. Now we simplify this to obtain 5 into 6.2, and that will give us 31. This will give us 31. So the mean of the first 5 terms will be equal to 31 divided by 5, and this will give us 6.2. Now we have this, the first 3 terms of an AP are x plus 1, 4x minus 2, and 6x minus 3. So we are finding the value of x. So these are the terms. So we can use any 2 consecutive terms to find the common difference. So the first and the second term, we are using them to find the common difference, and this will give us 4x minus 2 minus into x plus 1. Now this will give us 4x minus 2 minus x minus 1, and we simplify to obtain 3x minus 3. Now we can also use the last 2 terms to find the common difference, which is 6x minus 3 minus 4x minus 2. Now we expand and simplify to obtain 6x minus 3 minus 4x plus 2. And this will give us 2x minus 1. So these are all common differences. So they are we can equate them because they are equal. So we have 3x minus 3 is equal to 2x minus 1. So we group like terms to obtain 3x minus 2x is equal to negative 1 plus 3, hence our x equal to 2. So we now find the sum of the terms of the progression, but we know we can find the first 3 terms now by substituting the value of 2 into the expression. So we get 3, 6, 9 to be the first 3 terms, and we were told that the last term is 18. So u sub n equal 18 equal L. Now we can rewrite this as 18 equal u sub n, but we know that u sub n is having the expression a plus n minus 1 times d. So now we find the common difference in the first term, which is 3. The common difference is equal to 6 minus 3, which is also 3. So we substitute these values into the expression to solve for n. So we have 18 equal 3 plus n minus 1 times 3. So we divide through by 3 to obtain 6 equal 1 plus n minus 1. And we simplify to obtain n equals 6. So we have 6 terms in the sequence. So the sum of the first n terms is given by n over 2 into a plus L, which is the last term. Now we have the sum of the first 6 term equals 6 over 2 into the first term, which is a, plus the last term, which is 18. The first term is 3. So the sum of the first 6 term equals 3 into 21, which will give us 63. Now let's take another example. We have this, the first term of an AP is equal to thrice the common difference, so A is equal to 3D. Now if the common difference is equal to 8, then the first term becomes 3 times 8, which will give us 24. Now we know the use of n is given by a plus n minus 1d, and this will be equal to the first term. So use of 6 will be 24 plus 6 minus 1 times 8, and this will give us 24 plus 5 times 8, and this will give us 24 plus 40, which is 64. So the sixth term is 64. Now we have this, the nth term of an AP is given by use of n equal n squared log 5. So we are finding the first n terms, the sum of the first n terms in terms of log 5. So use of 1 will be equal to 1 square log 5, then this will give us log 5, and use of 2, which is the second term, will give us 2 square log 5, and this will give us 4 log 5. So we need to determine the common difference now. So the common difference, which is d, is given by the subsequent term, which is u2 minus u1. Now we have 4 log 5 is equal to 4 log 5 minus 4 minus log 5, and this will give us 3 log 5. So now we substitute this into the sum of the first n terms given by n over 2 into 2a plus n minus 1d. So we have sum of the first n terms of the logarithm of the sequence is given by n over 2 into 2 log 5 plus n minus 1, then log 5. N minus 1, then 3 log 5, which is the common difference. So we now apply, so 3 log 5. We now apply the properties of logarithm. So we have n over 2 into 2 log 5 plus 3n log 5 minus 3 log 5. So this simplifies to n over 2 into 3n log 5, 3n log 5, then minus log 5. So we simplify further using the laws of logarithm. Now they are subtracting, so the logarithms, the numbers will divide. So we have s of n equal n over 2 into log 5 to the exponent of 3n divided by 5. So this will give us log 5 to the exponent of 3n minus 1. Now we apply the property again so that the multiplier comes to the. Now we have this, we are finding the sum of all the odd terms from 51 to 99. So we have the first term to be 51. So now we can write down some few terms of this sequence: 51, 53, then 55, 57, and so on. So the common difference will be equal to 2. Then we have the last term to be 99. Now use of n is given by a plus n minus 1d. So we need to find the number of terms in the sequence. So we have 99 is equal to 51 plus n minus 1 times 2. So we use this to solve for n. So 99 will now be equal, 99 minus 51 will now be equal to 2 times n minus 1. So we have 48 is equal to 2 times n minus 1. This implies that 24 equal n minus 1. So n equal 24 plus 1, which is 25. So we have 25 terms. So the sum of the first n terms is given by n over 2 into a plus l, since we know the last term. So we substitute the n equal 25 and the a and the l. So s of 25 will now be equal to 25 over 2 into a, which is 51, plus l, which is 99. So the sum of the first 25 times will be 25 over 2 times 150, and this will give us 25 times 75, and this will give us 1875.